Today we're going to learn about stoichiometry. Specifically, we're going to learn how to go from grams of one substance to grams of another substance in a reaction. We're going to use three skills we've already learned. One of those is balancing reactions. The second is going from grams to moles and moles to grams. And the third skill we've learned is how to use factor labeling to solve problems. So we're going to use all those. We're going to do one thing that's new today, and I'll emphasize that when we get there. So, when you know the quantity of one substance in a reaction, you calculate the quantity of any other substance. This could be a substance that's consumed. If it's consumed, it would be a reactant. Or created, if it's created, it would be a product. So we're going to be calculating the quantities of both of those. Products created, reactants consumed. Now, quantity could also be expressed in terms of liters, tons, or molecules, but today we're going to emphasize and use mostly grams and moles, and actually only grams and moles. So the definition of stoichiometry is the calculation of quantities in chemical reactions, and that's what chemists refer to as stoichiometry. You may want to write this definition down. Calculation of quantities in chemical reactions. There's 4 steps for gram-to-gram problems. Please write these 4 steps down. I would recommend that you write these on a note card, and you can pull out this note card and use it all the way through the unit except when you get the final test, and at that point hopefully you'll have those memorized. Of these 4 steps, you've done 3 of them before, only 1 is new. Let's begin. First step, write a balanced reaction. I think everybody knows that. A lot of times the reaction will be given, and we'll just start from there. But you need a balanced reaction to do these problems. Step 2. Convert grams of given to moles of given. So, for example, the problem may say there's 25 moles of sodium hydrogen carbonate. You'd have to convert that to moles. And I think everybody here knows to do that, you'd put grams from the periodic table on the bottom, so you'd have to figure out the molar mass using the periodic table that you have in your calculator. And then at the top, you would just simply write 1 mole. And then your grams would cancel and you get moles. Now, the next step, number 3, is what's new. Convert the moles of given to moles of unknown. So you're going to go moles of given to moles of unknown. And to do this, we're going to use a mole ratio. In order to do this mole ratio, you have to have a balanced equation. So you'll have to use a balanced equation for that part. Number 4, convert moles of unknown to grams of unknown. And you've done this before too. So if you're starting in moles, you want to know go to grams, you put 1 mole at the bottom, and you put the mass in grams from the periodic table right here. And the mass in grams would depend on what substance you're using, because we know all atoms have different masses. If it's carbon, it's 12.01. If it's helium, it's 4. If it's carbon dioxide, it's 44, so forth and so on. So let's do a couple of these problems. Now, the first problem we're going to deal with is actually the creation of, do you have any idea what substance we're going to talk about creating? Ammonia. Now, ammonia is also used in fertilizers. It's used in cleaning products. So, as you recall, ammonia is used as a fertilizer, and to produce it, what they do is react nitrogen with hydrogen. And here's the balanced reaction. Nitrogen, I'm not sure if you remember this, is diatomic. It reacts with hydrogen, which is also diatomic. And so when you have diatomic nitrogen and diatomic hydrogen together, they react in a 1:3 ratio and produce 2 moles or 2 ammonia molecules. So the ratio we get from this is a 1:3:2, and we're going to use that ratio when we do these problems. So here's how ammonia is produced. So here's our question. Do you see the mass and atoms are conserved in this chemical reaction? So that's what I'd like to talk about, is when you do these reactions, we balance equations show that you have the same number of atoms on the reactant side, and you have the same number of atoms on the product side. That shows that the number of atoms are conserved. And if you were to weigh or take the mass of these reactants, the mass of your reactants would be equal to the mass of your products, because all the atoms weigh the same. We've not lost any atoms. All we've done is broken some bonds, reformed them, rebonded them, and formed a new substance. So we say mass and atoms are both conserved in every chemical reaction. So the mass of the reactants equals the mass of the products. The number of atoms of each reactant equals the number of atoms for the product. So let's do a problem. So this is a roadmap that we're going to be doing to do the 4 steps. We're going to go from mass of A to moles of A, from moles of A to moles of B. This is where we use a new thing, the mole ratio from the balanced equation. Then we'll go from moles of B to mass of B. So here's how these problems work. First, you'll be given a mass. you'll convert that mass to moles. Now, where are you going to get this number of grams from? Hopefully you're going to remember this grams right here. This is going to come from your periodic table, depending on what substance it is. And your molar mass, that will be the molar mass of A from the periodic table. And now we're going to change moles of A to moles of B. And this is the ratio we get from, this is step 2. This is step 3. Step 3 is the mole ratio from the balanced equation. And the moles of, and this is our mole ratio. So the moles of A would cancel with moles of A. Now we have moles of B. We don't change that to mass. And so we want to put mass at the top and moles at the bottom, so moles cancels. And this molar mass here, once again, this would come from the periodic table, just like this mass came from the periodic table. And notice the number of moles we use in the second and the fourth step. This is our step 4, our final step. Both of those are always 1 mole. The only time you have a number other than 1 is in the mole ratio, and that depends on your balanced equation. So let's do a problem. Here's a problem. Calculate the number of grams of ammonia, NH3, produced by the reaction of 5.40, 3 significant figures, of hydrogen with excess nitrogen. So here's our balanced equation where I had that. Hopefully you wrote that down. That's a very important equation to write that down. And we're going to skip that and go start doing the problem. So here's the steps. Grams of hydrogen to moles of hydrogen. Moles of hydrogen to moles of ammonia. That's our unknown. Moles of ammonia to grams. So the first step, these are our 2 knowns, and the ammonia is our unknown. So let's solve. So first you start with the 5 point, and it's going to be a 3-step problem. So you have 3 factor labels. So first you want to change grams of hydrogen to moles of hydrogen. You look on the periodic table, and hopefully you find the molar mass of hydrogen right here. Multiply that by 2 because hydrogen's diatomic. And so our given value, then you write 1 mole at the top, 2 moles, remember this is from the periodic table, the 2, and that goes in the bottom. The grams of hydrogen cancel, and now you have moles of hydrogen. This is our brand new step. Pay close attention. We want the mole ratio of hydrogen to nitrogen from the balanced equation. Now we see from the balanced equation there's 3 moles of hydrogen for every 2 moles of ammonia that are produced. So that's a 2 to 3 ratio. You always, always, always get that number, that ratio from your balanced equation. So when we do this, the moles of hydrogen cancel in our mole ratio. And now we have moles of ammonia. Now we have one more step. The last step is to change moles of ammonia to grams of ammonia. So this is where we once again use the molar mass that we get from our periodic table for ammonia NH3. Nitrogen's 14, hydrogen's 3, so that should be 17 grams. So we're at 17 grams at the top, and we write 1 mole at the bottom. And that changes our moles of unknown to grams. And then we get our final answer, which is 30.6 grams of NH3. And notice that was our reactant. That's what we started with. Our known, and now we change it to our unknown. Both those have 3 sig figs. Please write this down. Hopefully you can do some more problems like this. We'll get lots of practice tomorrow. Have a good night. We'll see you.